So it says, how many ways can 3 friends be arranged in a line? So if I picked 3 of you, and I'm just going to pick the first 3 that I see, is Alec, Charlie, and Courtney. And actually, sorry, Courtney, but I'm not going to pick you because I only have 2 C's. I'm going to pick Talon. Because then I have different letters in their name. So how many ways can these 3 friends be arranged in a line? Well, there's one right there. I could do Alec, then Charlie, and then Talon. Okay. Then I could just switch up Charlie and Talon. I could do Alec, and then Talon, and then Charlie. Okay, so there's 2 ways right there. There are 2 different ways. Then Charlie could go first, and then Alec, and then Talon. You could do Charlie, Talon, and then Alec. Just switch up the last 2. There's another 2 ways. And then Talon could start first, and we should end up with 2 more ways there too. Talon, Alec, Charlie, Talon, Charlie, Alec. And that's it. That's all the possibilities that we have to arrange 3 friends in a line. Now, maybe a quicker way to do that would be thinking of it as 3 spots. Instead of trying to list out all the possibilities like we did, sometimes there's going to be hundreds of different options, and you'd never want to try and list all those out. It'd be crazy. So I just think of it as like position 1, position 1, position 2, and position 3. Well, how many choices do we have? If I have Alec, Charlie, and Talon just kind of bumbled up in a group, how many choices do I have for that first spot? Well, I have 3. I can pick any 3 of those people. So I have 3 choices there. Now I pick one of them, let's say Alec. Now for the next spot, I only have 2 choices left over. And then for the last spot, I just have 1 left over. And if I multiply those across, 3 times 2 times 1, that would be 6. Those are like 6 options. Now you don't get the specific options, you just know that there's 6. But we can use that for doing even ones like the next one that are going to be even more. If we had 4 friends, I added someone. So we're going to have Alec, Charlie, Talon, and Wesley. Courtney, you're lucky your name starts with a C. Alec, Charlie, Talon, and Wesley. And that's super sloppy, but like I said, we're not going to try and list all these out. It wouldn't take a long time, but it'd take more time than I want to spend on it. So we'd just think of it as 4 spots, like 4 positions in the line. For position 1, I have 4 choices. And then I have 3 choices, and then 2 choices, and then the last choice. And if I multiply all those together, I'd have 4 times 3 is 12, times 2 is 24, times 1 is 24. So there'd be 24 ways. And I don't need to list out all 24 ways. It's just looking for how many. So I like to think of it as like positions or like groups of things. And we'll get into more detail with that here in a little bit. Okay. Today, actually this first half of the unit really isn't a lot of probability. It's just a lot of counting. And maybe I call it like grown-up counting because it's not just like counting individual one by one. Maybe like some of y'all did those number talks. It's just counting, different ways to count, different ways to count large groups of things. So this factorial, this exclamation point is called factorial. Okay, and I don't know if you've seen it before or not.
They do that freshman year.
Do they? Awesome. Yeah, factorial is just it's a way to like write out super large numbers in just a smaller way. So 9 factorial, we just do, write it out as 9 times 8 all the way down to 1. So 9 times 8 times 7, 6, 5, 4, oh my gosh, 3, 2, and 1. I didn't leave myself a lot of room here. So that's what factorial means, is you just list it out starting from the number you're given and go all the way down to 1. Kona. And you can type that in. You could like type it all in individually or whatever, 9 times 8 times 7. Or I think on Desmos, I'm going to open it up, and I didn't mean to do that, but I'll do it anyways. If you type in 9 and go to functions, it should be in there, and it is not. Let me try and just go to like that. There we go. There's an exclamation point in there. Just like on your keyboard, if you go to the alphabet, there should be an exclamation point there. And then it gives you that number, 362880. So we could do that. I'm sorry. Come here. Come on.
Come on.
All right. So 6 factorial, we could write it out. 6 times 5 times 4, all the way down to 1. Or if we plug it in Desmos, I'm going to try and do it like this. It's not letting me do it. 6 factorial is 720. 6 times 5 times 4 times 3 times 2 times 1. Now with some division, there's ways that we can shorten it up. So you could just type this in, 8 factorial divided by 6 factorial, and get your answer. Or if we wrote it out, so I'm going to write it out for this one, and then we'll do it the short way the second time. If I wrote it out all the way down to 1 on top, so 8, 7, 6, 5, 4, 3, 2, and 1. And then on the bottom part would be 6 times 5 times 4 times 3 times 2 times 1. Okay. Now when you're division, like doing division, and you have the same on top as you do on bottom, they just cross out. So the 6's go away. The 5's go away. The 4's, 3's, 2's, and 1's. They all just cross each other out. When you have the same thing on top as you do on bottom, they'll just cancel out. So then all that's left is the 8 times 7. Which is 56. Okay. So sometimes we can do this a lot quicker. With the 14 on top and the 10 on bottom, we could do 14 times 13 times 12 times 11, and then times 10 factorial. I'm not going to keep on writing it out, because then on bottom, I'm just going to leave it as 10 factorial. And if I have the same thing on bottom as I do on the top, then they'll cancel out. Okay. To 14 times. So when you, it's almost like you're looking at the 14 and 10, and you know that everything after, if you just started writing out the top as 14, 13, 12, 11, and then you know the rest will cancel out when you have that division. So you can just type that part in then. and I get 24,024. So just some like shorter ways to actually plug it in. Like I said, if you did, I don't know why it's there, it goes. If you did 14 factorial divided by 10 factorial, you could type it in like that. That's not a problem. If you're okay with that, then go right ahead. That's fine. Just showing like shorter ways to do it, or what it means when you actually get that number of 24,024. Okay, so sometimes we use these factorials to help us write like really, really large numbers or really large ideas, and sometimes we don't need them at all. Okay, so for like these next two, we don't need them at all. We don't need factorials, but in the future, we will. So this is more of like the counting principle, which is the title of these notes, is like organizing groups of different things is how I see the counting principle. Seeing how many ways we can group things together. So it says how many outfits can be made. I have a red, blue, and gray shirt, a blue, black, and khaki pants, and then black and brown shoes. How many different outfits can we make? And I don't care if they match. If y'all have seen my wardrobe, you know I don't care about that. I just look at our three groups that we have. We have shirts. We have pants. And we have shoes. Okay, well, how many choices do we have for shirts? How many choices for pants? And how many choices for shoes? That's all it is. 3 times 3 is 9, times 2 is 18 outfits. So we'd have 18 total outfits to choose from. That's like 3 weeks of school you could get through with just 3 shirts, 3 pants, and 2 pair of shoes. Okay, so for the last one, we're just making up meals. One item is selected from each of the 4 groups. How many ways can a meal be ordered? So we have the main course, vegetables, a beverage, and then dessert. I have 4 choices for my main course, 3 for vegetables, 4 for beverages, and 3 for desserts. And then you just multiply them together, those groupings. And here's my little number talk here for you. You have 4 times 3 is 12, and 4 times 3 is 12, and 12 times 12 is 144. So there's a whole bunch of meals that you could, like a different combination of meals that you could get with just those options. Okay. So there's some practice on the back, and I do want to go through a few of those with you.